Today we are going to be learning about function notation. Function notation is a way to write functions where x is the independent variable and f of x is the dependent variable. Now, what is an independent variable and what is a dependent variable, you may be asking? An independent variable is a variable that does not rely on something. Let's say a child, for example. A child depends on its parents. An adult does not. What would be the independent variable? The adult would be the independent, and the child would be the dependent. Now, in terms of math, we use function notation to show the function which is dependent on the variable. The most common form of function notation is written as so: f of x. This means the function is dependent on the variable x. Whereas x just equals a number. It can be also shown as this: f of x equals y. The function x equals a value. The function x equals a value. X equals x. When plugging in x to the function, you'll get an output. Let's start to use numbers here. F of x equals x minus 3. This is a dependent function on the variable x. We know it is dependent by the x in the parentheses circled. This function will give us an answer if we are given a value for the x. So if x equals 5, f of 5 equals 5 minus 3. What's the answer? 2. Therefore, f of 5 equals 2. But f of x does not equal 2 because your x is a generalized formula. F of x changes with value of x. Let's graph this out. F of x equals x plus 1. F of x in this case is going to be our y. This is the most common way to represent f of x. We can make a table to help us find our solutions to this. When x is 1, f of x is 2. We take this, or whatever number we're using here, and we plug it back into the function. When x is 2, f of x is 3. We are taking 2 and we are plugging it back in and getting 3. When x is 3, f of x is 4. We can then take these values and plug them back into the graph to represent this function and the change it makes on the x. When x is 1, f of x is 2. When x is 2, f of x is 3. And finally, when x is 3, f of x is 4. Function notation is vital to your understanding of algebra and advanced mathematics. If we are asked to evaluate f of x at a certain x point, how shall we solve this? Well, let's say our f of x equals 4x minus 9. When x equals 3, what is f of x? F of 3 equals 4 times 3 minus 9. This equals 12 minus 9, which equals 3. Therefore, f of 3 equals 3.